In this course, we're going to create a simple 2D game where you, as a player, avoid the falling boulders. And each time you successfully avoid the boulder will respawn and 1 point will be added to your total score. And when the boulder hits the player, the game over screen appears and we can press restart to restart the game. This course will teach you how to create the first Unity 2D project and how to implement things like basic game logic, player movement, collision, using random values in your game, adding a dynamic scoreboard, and finally creating a game over screen where you can restart your game. So the first thing you want to do is open up the Unity Hub and start a new project. In this project, we're going to use the universal 2D template. I'm just going to name my project Boulder Avoider, but you can of course name your project whatever you want. Click Create Project. So after an incredibly long wait, the Unity editor should open up. So the first thing we're going to do is add our player to the game. Here you have your scene view, you have your game view. This is what you'll see in game. I'm actually just going to take this tab and drag it down here. I like to see my scene and game view simultaneously. Now that we can see our game and our scene view at the same time, I'll just go ahead and right click here in the hierarchy, go to 2D object, sprites, then I will add a square. You can add whichever shape you want. I'll just use a square and I will call it player. I will move it a bit down because we'd like our player to be somewhere around here. And just to make it easier to see, I'll just make it red. We will be adding an actual sprite later at some point, but right now we just need to get the movement working. So to get the movement working, we will be using the input system. So I will go back into project. I will create two folders we're going to need. You can either right click, create, and then folder, or you can hold down Control Shift and press N. And I will create two folders. I will call one folder scripts and the other folder I will call input. I will go into my input folder. I will right click, create. Down to the bottom, we can create a new input actions. I will call this layer controls. And then here in the inspector, you can see we can tick this called generate C# class and hit apply. This will create a new C# script called player controls. As you can see, this can look a bit confusing, but we won't be editing in this script. This is just how the new input system works under the hood. So now let's edit our input actions. We will go to this player controls, double click it to open it up. And you can see we have these different tabs in the input actions editor. I'll go through them one by one as we create them. On the left, you have your action maps. We can hit this plus sign to create a new action map, and I will call this movement. Think of an action map as a specific control scheme for a specific scenario. So let's say that in our game we could enter and drive a vehicle. Well, we could call this vehicle controls. Not sure if I spelled vehicle correct there, but you get the point. So we can have one for movement, walking, running, whatever, and we can have one for vehicle controls. We can add one for combat as well, etc. Let's just delete this vehicle controls as we won't be needing it right now. Then here we have our actions. But first, before we create a new action, we will need to go to the action properties here on the right. And we're going to change the action type from button to pass through. And then the control type, we will be using a vector 2, as we will be moving on two different axes, X and Y. And then here, if you expand the new action, there's this binding that comes as default. We can delete this before we go any further. Right click new action and rename it. I will rename mine to move. And now we can create our movement system. Again, naming does not matter at all. You can call it whatever you want. This just makes it clearer for me and hopefully you as a viewer. So I will click this plus sign and I will add what is called a up, down, left, right composite. You can see it adds this 2D vector. We can expand this as well. And here you have your bindings for up, down, left, right. As you can see, there's no bindings for any of these as of now, but we can click these bindings. We can go out here on the right to binding properties, click path. You can set this either here, or the easier way might just be to click this listen button. And then I will click, as we're on the up binding, I will click W on my keyboard, and this will register that I pressed the W key. So a bit easier way to set these. I'll set S for down, I'll use A for left, and I will use D for right. Before we exit our input actions editor, you can see this asterisk here, just means we haven't saved it. So I will go ahead and save my asset. So now that that's saved and compiled, let's exit out the input actions editor. And if you mark the script again, you can see here in the inspector, we scroll down a bit and you can see this added some input actions. It's called player controls, movement, and move, just as we named ours. It uses a 2D vector and it uses the bindings up, down, left, and right. So again, we're not going to go into this script at all. Just to show you this how it works under the hood, and it has registered what we've added to our input actions map. We're going to go back into the assets folder and now into our scripts folder, and we're going to create a new mono behavior script called player controller, not to confuse with our player controls input actions map. Now that is done compiling, we will just, before we go into the script, go to our player. We'll add a few components. We can start by dragging our player controller script over here to the inspector. Now that's added to our player. And we will also be adding a rigid body. Remember to add the rigid body 2D. We will not be using gravity for our player, so we will set the gravity scale to 0. And to make sure collision works properly, we're going to set this from discrete to continuous. Now we can open up our player controller script. So when we first open up our Visual Studio or whatever code editor you are using for this is what you'll see. So we have two methods here. We have the start method and the update method. When you create a new mono behavior script in Unity, this comes by default. You don't have to use these, but a lot of the times you will be using these. As you can read from the comments, start is called once before the first execution of update after the mono behavior is created. So when you start the game, whatever happens inside this block of code will execute once. And then you have your update loop, which is called once per frame. So if your game is running at 60 frames per second, whatever code is in this block will be executed 60 times per second. So 1 time per frame. I will be deleting these comments for now, as I won't be needing the comments and it will make it more readable for you, hopefully as a viewer. I will delete the start method as I won't be needing that as well. What do we need first? We will need a move speed of some sort to determine how fast our player should move. For that, I will create a private float and call it move speed. And I will set this to 1f. And actually, I will also add one more thing. Inside square brackets, before I create my variable, I will enter serialized field in square brackets. Serialized field is built into Unity as well. And this ensures that even though this is private and not public, this variable will show up in the editor and we can edit it on the go. I will just show you here in the Unity editor. We are at player controller, our script, and we can actually edit our move speed out here, even though it is private. If you're wondering why I'm keeping this variable private and not public, protected, or anything else as an access modifier, I will upload a video where I explain when to use serialized field, when to use private, when to use public, when to use protected, and the best practices, like where to keep your fields, where to keep your methods, where to keep your properties, so on. What we need to access now is the input action we created before. So our player controls. We can instantiate this from here by typing private player controls, which is what we called it. I will call mine player controls in this script as well. Now we will need some sort of direction for our player to move in. We will create a private vector2. As you can see, when I type vector, there's vector2 and there's vector3 and vector4. Vector2 is used when you use 2D axis, so X and Y. But if I were to create a 3D game, I would be using the vector3 as this has the C axis as well. But for this, we'll use a vector2 and I will call it movement. If you remember before, we also added a rigid body 2D. We will be needing this in our script as well. We added that to our player. So I will be creating a rigid body 2D. I will just call it rigid body. And for now, these are all the fields that we will need for this script. I will use another built-in Unity method called awake. Awake is called right before start. So also when the game starts up, this is called once. This is where we can do stuff like initialize our fields and get our components. So we will start by initializing our fields. We will use our player controls and we will set this to a new instance of player controls. So now we can access the input action map. And here comes a little show and tell and then a mini challenge for you. If in our game you look at our player, we have different components. We have the transform, the sprite renderer, our script, our rigid body. Sometimes you would use these components in our scripts and we will need to get these components. So for instance, let's say I wanted to get a hold of this sprite renderer component in our script. I would create a field for it, sprite renderer. Let's just call it SR for now. And in awake, I would be getting that component by typing SR, so the name of our variable, equal to get component. And then inside angle brackets, I would add the type of component we wanted to get, in our case, a sprite renderer, and then finish off with open close parentheses and a semicolon. So now I can use this, for instance, down in update in our other methods. I can use sprite renderer and then all the methods that's attached to our sprite renderer. We won't be needing our sprite renderer right now, so I will be deleting this once again, but now a mini challenge for you. We will need our rigid body 2D component. So try and get that component. So the challenge for you is try to get that component in Awake. I will give you a quick sec to pause the video so you can try this for yourself. And then afterwards you can follow my solution. So to do this, we need to access our rigid body. We've already created this up here. So we will access our rigid body and we will set this to get component rigid body. We need to remember it's rigid body 2D and not just rigid body. And then open close parentheses and semicolon. So now we have the rigid body, and this is all we need for our awake method. Now, before the player controls will actually work in our game, we need to enable it. What do I mean when I'm saying enable? If you go to Unity editor, you can pick any object in our game scene. You can see here, we'll just take our player in this example. I can go to the inspector and I can untick this. Now it is invisible in the scene. It won't interact with anything. It is disabled. So now when I tick the box here, it's enabled. So enabled just means the object is active in the scene and can interact with the game, while disabling is the opposite. There's built-in methods in Unity for this. We will use the method on enable, and in here you will just type player controls, so our variable dot enable. In our game, we won't be disabling the player, but it's still good practice that when you enable something, you should also have a case for disabling something. And another mini challenge for you, now try to add the method for disabling our player controls. Again, I'll give you a quick sec to pause the video so you can try this for yourself, and then I'll show you how to do it. For this, it's kind of similar to how we enable the object. We will just type private void on disable, and in here, you guessed it, we will type player controls dot disable. And now we'll use the next method in Unity, which is built in. We have the update. And this is a really good place, as this is called every frame, to register inputs. So for instance, if we press the WASD keys, that should be registered, and then we should move accordingly. And we need to register that input inside of update. But not to make update too long and too messy, we will actually keep it inside our own method and call it inside update instead. So we will be creating a new method, private void player input. And just to make sure we don't forget, we will just call it up here in update. We will be needing our movement direction. So this variable we created up here, private vector2 movement, and we will need to set this equal to something. This line can be a bit of a tongue twister, but I will write it and then I will go through it with you. We will need to set it equal to player controls dot movement dot move dot read value, and inside angular brackets we need the type. Which type are we reading from? We are reading from a vector2, then parentheses and semicolon. Now, why am I typing all of this? Where do I get this from? If you go back into the Unity editor, go to your input folder, and then inside this player controls input action map, we will open this. This is called player controls. We've called our input action player controls. We've created the action map called movement. Then we have the action move, which utilizes a 2D vector. And in our script, we have player controls, so the name of our input actions. We have movement, the name of our action map. Then we have move, the name of our action. And then we read the value of a vector2, so the 2D vector we are using. And just to show you this in action, if we type here debug.log, this is just to write out to the console. So if you want to check any variable and write it out to the console as you play the game, you can do that using debug.log. And we will write out our movement. We need to specify an axis. I will just use the x-axis. I will just drag my game tab up here so we can see the console simultaneously with the game view. When we start the game, this is constantly spitting out 0. This is the movement.x currently. If I press the D key on my keyboard, it will go to 1 because it's now positive on the x-axis, meaning that it's moving to the right. And if I press A, it will go back to -1. And if I press no keys, it will go back to 0. So -1 for negative. When I press A, moving to the left, D, moving to the right, no keys, it will stand still and have no x value inputted. So now that we know that our input is registering correctly, we can remove this debug.log as we won't be needing that anymore. And then we need to create a new method for actually moving our player. we will create a new private void called move, and we won't actually be calling this method in update. Usually it's best practice to use update to register player input, but when you're handling stuff like physics and movement, we will be handling this in another built-in method called fixed update. And here we will call our move method. So we have update and fixed update. Now to move the player, we will need to access the rigid body that we created earlier. So we will say rigid body, and it has a built-in method called move position. So it moves the rigid body to a position. And to do that, we will need to specify our current position and add our movement direction to it. So our current position is our rigid body dot position, and the direction we're moving in would be movement. And right now it will stand still because our movement speed is currently 0, but we can multiply this by our move speed, so the float we set right at the start of the script. And then we will need to multiply this with time dot fixed delta time. You may be scratching your head right now saying, well, what is delta time? Delta time is to make the game frame rate independent. So even though you have a beefy PC that runs this game at 340 something FPS, it will still move accordingly to the time passed in game and not your frame rate. It will move the same speed no matter the frame rate. Just a quick performance tip. Here we take a vector 2 and we're multiplying it by 2 different floats. It can be a bit better for readability, but also for performance to multiply the 2 floats together first. So we will just put this move speed times time.fixed delta time inside its own parentheses. So we only have to multiply the vector 2 by 1 float. Save the script, and you should be able to move using WASD keys. It's a bit slow for my taste right now, so I'll go to my player object. This is why we serialize the field, so I can edit this on the go. I will set it to 5, try this out instead. Yeah, it feels a bit better. You can play around with it a bit, make it a bit faster, make it a bit slower. This is why we serialize the field, so you can edit this on the go. Just remember, if I try to hit Control S now, as it says, you must exit play mode to save the scene. So if we stop the scene, this will go back to 1. Maybe I don't remember the value I actually set when playing the game. I can fix this by just going to the 3 dots here for our component, and I can go to copy component. And when I exit the game and this is set back to the original move speed, I can click the 3 dots again and then paste component values. So now this is set to the value I set while in play mode. Just remember, this won't change what you set in the script. So even though this actually won't change anything, just best practice to keep the same value in your script as in your editor. So now we have a moving player. Now comes the next step, which is adding our boulder to the game. I'll just switch this tab so I can see the game view simultaneously with my scene view. And I right click in the hierarchy. I add a 2D object, sprites, and then I would add a circle to represent our boulder. I'll just call it boulder out here in the hierarchy. And to differentiate between the different objects, I'll just give it a contrast color like a green, and I'll move it up here. So it should start around here in the game. Now, when I showed you the gameplay, it may have looked like boulders just came falling down one after another. But what actually happened, this is kind of a performance trick. We just used the same boulder over and over again, so we didn't have to instantiate new objects. So what actually happened is the boulder falls from here, it falls down, and you can see this white square, this white outline. This is what we can see in the game. So if I move just inside the white square, you can see the boulder here. If I move it outside, you can't see it anymore. And what actually happened is when it exited the boundary and was not visible to the player, what actually happened was that I respawned it by resetting its Y position to around here, I believe, and I gave it a random X position between the left and the right screen boundary. So this is what we want to happen, but let's start out simple by just making it fall down. For this, we would need to add some behavior to our boulder. We can do this best way by adding a script. So we can click add component. Then I can just type whatever name I want from a script. I will type boulder behavior. As you can see, it's just a new script as it can't find anything called boulder behavior. I will create an add, and then by itself, it actually registers, oh, we have a folder called scripts. Maybe I should put it in here. I'll save it right here in the scripts folder. We will be needing the start and the update method, so I'll keep these for now, but I will delete the comments. Now to make the boulder fall down towards the bottom of the screen, what we first want to do is create a variable which can represent the speed of the boulder. And this is actually the first challenge of the video for you. I would like you to add a variable that can represent the speed of our boulder, and we need to be able to change this variable outside in the Unity editor. If you're not really clear on how to do this, go check out my last video where we added player movement. And if you followed the last video, you might have your player controller script still in your scripts folder. You can go have a look at that as well. But now I'll give you a quick sec to pause the video so you can try this out for yourself, and then you can follow my solution afterwards. So if we go into a player controller script, you can see here we created a private float called move speed, and we used serialized field to keep it private, but still be able to change it in the Unity editor. We will do the same again here. We will, in square brackets, type serialized field, and then I will create a private float. I will call this boulder speed, so I can differentiate easier between the different kind of speeds we've created. And I'll just set this to 5F, same as our player. Now that we have the speed, we can actually make it fall down the screen. So last video, I stated that fixed update, another Unity built-in method, is best for handling physics. That is when we use the rigid body. We want this downwards movement to be constant as well, but we're not using physics in the same way as we're not adding a rigid body to our boulder component. So that's why we can just do this in update. So for instance, if I wanted our boulder to move toward the right, then we have this component, the transform of the game object. I could access the transform just by typing transform, the transform of the game object, so our boulder, and we can use the built-in transform method called translate. Moves the transform along its X, Y, and Z axis. And then it gets a bit more confusing from there on. But just remember the first part, moves the transform. So we move the object. And we do this by using parentheses. It says it needs a vector 3, but we can also use a vector 2. So we can, for instance, create a new vector 2. And then we need the X and the Y axis. If I wanted to make it move to the right, then I could tap 1 to make it move 1 pixel to the right each frame. And to get it to move to the right, I would like to keep the Y axis as 0, as I don't want to move it up or down. And then when we exit the parentheses, we can multiply this by the speed of our boulder, and then multiply this by time dot delta time. And again, a good performance tip, multiply the floats together first. So we can do it like this. Then we multiply the two floats together first. Save this script. And then in the Unity editor, when we play our game, as you can see, it moves to the right and it just continues outwards forever and ever. That's actually shorthand of writing this. Instead of writing new vector or creating a new vector variable, I could actually just write vector 2 and then dot for the extension methods, and it has a right. So a shorthand for writing vector 2 1.0, which is actually the value we wrote before. So if I type vector2.write, save the script again, then I can start our game, and it has exactly the same behavior, but vector2.write is a bit easier than reading new vector2 parentheses 1.0 parentheses end. So now the next challenge for you, instead of making our boulder move to the right, try to move it downwards. I will give you a quick sec to pause the video so you can try this out for yourself, and then you can follow my solution afterwards. So this is a fairly small change. We could create a new vector 2 and just set it to 0 on the x-axis as we just want to move it downwards, and then -1 on the y-axis. Now this would work, but as we saw before, it can be more readable to just use vector 2 dot the direction we want to move towards. So it had right, but it also has left, up, and the thing we need, down. So as you can see, this is shorthand for writing vector 2, 0, point, -1. Go back into the Unity editor. When we play, it moves downwards. So now we have two ways of moving. We have the rigid body, which we use to move our player, and we have the transform, which we use to move the boulder. So there's two different ways of making objects move. Just to show you, there are multiple ways to make objects move in the game. Now to reiterate what we wanted, when we play the game right now, it just continues and goes down and down and down until we stop the game. So now let's go to the next step. What we want is that when it exits the bottom boundary, it respawns up top. So how would we do that? Well, we need to set some sort of boundary for our screen, and that would be a position. And a position in Unity or transform position is normally represented by a float. So we could create variables up here for the boundaries of a screen. We could create a private float called screen top. We could create one as well for the screen bottom. That's just why we added. Create one for the left side of the screen and one for the right. So now we have the top, the bottom, the left side, and the right side of our screen. Well, how do we set these bounds to actually be active in our game? Well, what we could do to define our boundaries is find the exact value of the boundary. So if we move it all the way downwards, let's say we wanted the bottom boundary of the screen to be here, we could set it to minus 5.35 on the y-axis, but this would not be very dynamic. Let's say you made your game view bigger. Let's say you ported this to a mobile phone. Well, then these values would change. The screen wouldn't be as wide. It might not be as tall as when you play it on a PC. So therefore, we will use dynamic values instead of hard-coded values. So now we need to define what our boundaries are, no matter the screen size. To do this, we can access this main camera and then access its field of view, so what it sees as the game screen. First, we will access this camera by typing camera. We will just call it main camera equal to camera dot main. So now we've accessed our main camera of the scene. So the object you see out here in the hierarchy, main camera. And you can also see this is actually tagged as the main camera. Now we will need some kind of height and some kind of width for our camera. So I will create the float cam height, and this is equal to main camera dot orthographic size. This can be a bit confusing, but I will explain this in a minute. Now we will need to create our cam width, and for this I create a new variable called cam width, and I will set it to cam height times the main camera dot aspect. So now what we've essentially done, using these three variables, we can see how far there is from the camera to the boundary of the screen. And where is our camera placed? Well, it is placed dead center in the middle of the game. Let's just set the vertical bounds first. So to set the vertical bounds, we can set the screen top, so the top edge of our screen, to our main camera dot transform dot position dot y, because remember right now we want the vertical angle, so up and down. That's why we're using the y-axis, and we will add our cam height to this. So we're accessing the y-axis of our camera, this transform dot position right in the middle of our game view, and we're adding the height of the cam to set the top screen bound. I realize this part can be very confusing, but don't worry, you'll get it at some point. Just think of this for now as we're finding our camera, we're finding the height and the width, so the field of view for the camera, and then we're accessing the transform of our camera, which is in the middle. And to set the top of the screen, we would take the position of the camera and we will add the cam height. So now for the next challenge, try to set our screen bottom. So find the bottom boundary of the screen. Again, this part can be very confusing, so don't feel bad at all if you can't complete this challenge, but give it a good go. Pause the video now, and I will see you in a bit to show you my solution. So to set the bottom boundary of our screen, we will again access our main camera and the transform that position on the y-axis, because now we're going downwards, so we're still on the vertical bounds. And instead of adding the cam height, we will subtract the cam height. So now we have the top and the bottom boundaries of our screen. Now we will create the horizontal bounds being the left and the right side of the screen respectively. So let's start by adding the screen left. Again, we will access our main camera transform position, but now we're going horizontally and not vertically. So not Y, but X. And remember now we're going to the left. So this, if I'm moving this to the left, see the X-axis, it's negative. So that's why we will subtract the cam width. Next challenge for you, try to set the right boundary of the screen. If this is too challenging for you, don't worry, it is a very difficult topic right now, so don't feel bad at all. But just try to look at this, how we set the screen top and the screen bottom compared to each other. Then look at this and think of it in the same pattern as how we set the vertical bounds. And then try to set the right side of the screen. I'll give you a quick second to pause the video and then come back to see my solution. So to set the right side of the screen, we will access our variable screen right. And once again, we will access the main camera transform position x, and with this time we will add our cam width. So now we actually have our screen boundaries. So now we can go down to our update method, and here we can check for the boulder's position, and to check, well, is the boulder underneath the screen, then we want it to be at the top of the screen once again. So we can check if the transform position y, we need it to be negative. So if it is less than the screen bottom boundary, then we would like to set our transform position of the boulder to a new vector 2. Let's just set it to 0 on the x-axis to make it spawn in the middle, and then screen top. Let's save the script, hop back into the Unity editor. Let's try to play this. So when it goes outside the screen bottom, it respawns at the top. That was the second step. Now we got it to move and to respawn. Now for the next and final step, we would like it to spawn randomly at the x-axis between the left and the right boundary. So how can we find this random x position? Well, we can create a new float and call it random x, and then we can set it equal to a method built into Unity called random.range. And as you can see, we need a min and a max. And inclusive just means that the number you set is included in the range. Let's just say the min was inclusive and the max was exclusive. Then if you set it to 0 and 5, then it will be between 0 and 4. As you can see here, when we're using ints, then it's inclusive and exclusive. But we are using floats, so therefore both the min and the max are inclusive. And what do we want the range to be? Well, we want the min, so the lowest number on the x-axis, to be the screen left. And what do we want the max to be? You might already have figured this out. We want it to be the screen right. So now we have our random x value. Now the next challenge for you is to change our transform.position, so where we spawn the boulder when it exits the bottom of the screen, to be at our random x position instead of just the middle of the screen. I'll give you a quick sec to pause the video and try this out for yourself, and then you can come back and see my solution. Well, actually, instead of just respawning it at 0, we would like to spawn it at our random x position. So if we save the script, jumping into Unity and start the game, as you can see now, when it respawns at a random x position between the left and the right side of the screen. Now, one final thing I would like to do before we end this video is that the update method is kind of looking a bit messy. We're doing a lot of things in the update method. We're moving the boulder and we're finding the random x value and we are respawning the boulder. So what I would actually like to do is that I highlight this part of the code and I will hold down my left control and press dot. And as you can see, this gives a quick action called extract method. I will click this. And what are we doing in this method? Well, we're moving the boulder. So we'll just call it move boulder. And this creates a new method and it automatically writes it in the update as well. So it's still called in our update method. And this part of the update loop is calculating our random x and respawning the boulder. I would like to extract this in a method as well. I can use the control dot, or I can just cut it with control X. And then I can create my own method, private void, let's just call it respawn boulder. And I can just paste it in here in the method body. And then I can call it up here, just to show you there's multiple ways of doing it. But by far the quickest is of course just to extract the method using the control dot extension. Now the last challenge of the video for you. This is a long start method as well. So for this challenge, I would like you to extract this code into its own method and then call it at the start method instead of just writing it directly in start. Pause the video now and then come back to see my solution. Well, just like we did before, let's just highlight all of this, hold down left control, press the dot. It gives us this extension where we can extract the method. I will just call it calculate boundaries. Actually, let's rename this. I'll just highlight it again, hold down control and press R twice. I'll name it calculate screen boundaries. I always like to be very explicit with my naming. So boundaries could be boundaries for anything. I would like to calculate the screen boundaries. So I'll change the name to that. And I would actually like it to be underneath the update loop. So I'll just cut it and then place it here. This is just my programming OCD. I like to have the start and the update, so the build methods first, and then the methods I've created on my own in the order that they are called. So we have calculate screen boundaries, move boulder, respawn boulder, and these are in the same order. So now we have our boulder spawning at the top when it reaches the bottom of the screen, and it's spawning at a random X position. The next thing we need to do is to add collision to our boulder so that a player gets destroyed when it collides with the boulder. So to add collision to a game, the first thing we will need is that the two objects that will collide will have colliders on them. So for our player here, we have this little square, our player, and we will add a box collider. As you can see, if I type collider, there's a bunch of different colliders, but since this is a square, a box collider makes the most sense. This is a 2D game, so remember to use the box collider 2D. And then we will also add, and then we have our boulder, which essentially works as our enemy. And here we will add another collider. So this is circled, so we will add a circle collider 2D. Unity actually handles the collision by itself. So if we run our game, you can see these two objects will collide and our boulder will actually push our player out of the screen. But now we need some functionality for this collision to actually do something for our game loop. So we will go to our player And I will actually head into our scripts folder and create a new script, and I will call it collision handler, because this script will handle our collision. So we will go to our player and drag our script on it as a new component. Then we will open up our collision script, and we will delete the start and the update method, as we won't be needing those in this script. And a very good thing about Unity is that the game engine actually handles collision logic for us. We just have to implement the correct methods. And when I say methods, I do this because there are actually multiple ways of handling collision in Unity. There are two main methods. I will show both of them to you right now. So the first one being on collision enter. You can see we have on collision enter and on collision enter 2D. We will use the 2D one for this game. And the other method would be on trigger enter. And again, we have on trigger enter and on trigger enter 2D. You can see both of these methods come with a parameter each. I will explain both of these parameters in a minute. But first, let's figure out which kind of collision we want in our game. Because what do we want to do in here? Well, we want to remove the player from the game. Let's just say first, we test out the on collision enter. But if we were to use a regular collision method, then the two objects in our game right now, the boulder and the player, can actually physically interact with each other. Let's say we hit it from the side like this. Now you can see our player is moved out from the scene, and it is actually in constant rotation because of this physical interaction. If we wanted the game to continue, well, this is not the kind of logic we want in our game. But if we go here to the boulder and we go to its collider component, the circle collider 2D, and we use this is trigger, we tick this box, then when collision happens in our game, as you can see, it actually moves straight through. And on screen, when you see it just moving straight through, it might seem like nothing is happening. But let's just go to our on trigger enter. Let's try using the debug.log. Say collision happened. Let's try to save the script. And now when we run our game, collision happens. And you can see here it debugs to the console, collision happened. So even though it's passing straight through, then we're still registering a collision. So that's why for this project we will not use the on collision enter. We will just use the on trigger enter. If you were to untick this is trigger and you're using the on trigger enter, nothing would actually happen. If however that this was ticked, but in here instead of on trigger enter we use the on collision enter, then again nothing would happen. So if at some point your collision in your game doesn't work the way you expected it to, then it's always a good idea to check the collider and to check if the is trigger is checked or not. But now we've confirmed that this method actually works, so let's remove our debug log. We won't be needing that anymore. As we noted earlier, when this method is created, it comes with parameters. Well, what is this parameter? As you can see, it's a type collider 2D. What collider 2D are we talking about? Well, the player is the game object which has this collision handler script attached to it, and this collider 2D is a reference to what it collides with. So in this case, this would be the circle collider 2D on our boulder, which is also why we've set the boulder to trigger and not our player, as this checks, well, does the thing we collide with have a trigger on it? So now what do we want to do? We want to remove the player from the game. So let's just say that the thing we actually wanted to remove from the game is our boulder. To remove a game object from the game during runtime, we would use the built-in Unity method called destroy. And as you can see, this removes a game object, component, or asset. Well, what does it take as parameters? It takes an object. So a game object. If we wanted to access the thing we are colliding with, we would actually use this collision variable. But this collision variable is only a reference to the collider 2D. So were we to run this script, we would actually destroy the circle collider component. We want to destroy the game object that the collider is attached to. That's why we use collision.gameObject. So let's save this script, jump back into Unity and run our game, and now when we collide, the boulder is destroyed. So here is the challenge for you. Change the logic of this method. So instead of destroying our boulder, we destroy the player. I'll give you a quick sec to pause the video, try this out for yourself, and then you can come back to see my solution. Now instead of accessing our collision, we actually just want to access the game object that this script is attached to. We do this by typing game object. So now this references our player instead of what it collides with. If we save this script and jump back into Unity, now our player is destroyed. Now at this point you might be tempted to think we're done, but we are missing one small detail. The thing being, if you were to develop further in this game, maybe the boulder is not the only object you'd like in the game scene next to the player. For instance, just to showcase this, I've added a triangle to our game. Let's just say this is some kind of pickup, some kind of power up we have in our game, and this is also a trigger and has a collider on it. But if we collide with this, instead of picking it up, the player is destroyed. This is not what we want to happen. Therefore, we need to only destroy the player or remove the player from the game if it is actually a boulder we're hitting. So to make sure that we are actually colliding with a boulder, we need to check for something. But what do we need to check for? For this, Unity actually has a very smart thing called tags. You can see here, if we go to any game object, it actually has tags. We used a tag in the last video where we set the screen boundaries. See, our camera has the tag main camera. Well, we can actually set a tag for a boulder. We have these tags which are built into Unity. Player, game controller, camera, etc, etc. These don't really fit for our boulder, so we can add a tag. Here we have a list of tags. You can hit the plus sign and then you can add a new tag. I will just add the tag of boulder. Then you go back into the boulders inspector. And now on your list of tags, you see a boulder has been added. So we tag this as boulder. And what we do now is that we go into a script and we use an if statement. And we can check that if, so we can access our collision variable. We can use the dot to access the extension methods. And we can use the compare tag. So it checks the GameAppX tag against the defined tag. The defined tag being what we set as a string in these parentheses. So we can set the tag of boulder. Make sure to spell it right, as it won't work if you misspell. And then in here, we want to destroy our game object. So now when we run a game, we can collide with this triangle, nothing happens, but when we collide with a boulder, the player is removed from the game. Now that we've added collision to our game, let's add a score to the game, which increases each time the player successfully avoids the boulder. Now the first thing we would like to do is getting our score to be visible on the screen. So therefore I will go into my hierarchy and I will right click and I will go to UI and I will create a text element. I will change the name of this text element to be score text. If you get a pop-up saying something with import TMP essentials, just import the TMP essentials and then you can close out the TMP importer. You're not able to see this on your scene screen right now, but if you go into your game view, you can see, for me at least, it's right here in the left bottom corner. It might be placed elsewhere for you. The reason we can't see this in our scene view right now is if we highlight the canvas object in our hierarchy and then press F to frame it, the canvas is actually much larger than our game scene. The game scene is this small square you can see in the bottom left corner. So firstly, let's place the score text where we want it. I would like to keep it in the left top corner. So I will go to my score text element and here you can see the square with kind of a crosshair on it. We open this and we would like to place it in the left corner, but I would also like to set the pivot and the position. So therefore I hold down Shift and hold down Alt. And then when I click here in the top left corner, it will set the text to be in the top left corner. So let's try to change this new text into our score. Now we want to go into a project tab and we want to go to our scripts folder and we will create a new mono behavior script and we will call it score manager. First off, I will delete the start and update methods as we won't be needing these. And now for the first time in this series, we will actually be using our usings. So think of our usings as kind of our tools in our toolbox. So now we have the using Unity engine. This unlocks the Unity engine tools, but we will also like to access our TM Pro text tools. So we will type using TM Pro. So the first thing we would like to do in our script is access the text element. We would want to set this in the inspector. Therefore, we will use the serialize field, and this will be of the type TMP text, and I'll just call it score text. Then I would like to set my score to something. Well, what do we need for a score? We would need a number. So therefore, we will create an integer. I will name it score, and I will set it to 0, as our score will normally start at 0. And now we need a method for adding to this score. I will create a public method, and it will be named add score. So what do we want to do in add score? Well, of course, we want to add to our score. You can add as many as you like. I'll just add 1 to my score. So therefore, I'll type the shorthand for that, which is score ++. Now we're adding to a score, but we're actually not doing anything to change the text. We can change the text by accessing our score text variable, and we can use the method called setText. As you can see, it takes in a string. For now, I'll just set it to score. And that is it for the script for now. I will reveal that something is missing, but we will add that at a later point. That's for a challenge later in the video. So right now we've added most of what is needed in this script, but we're actually not calling the add score method. We don't want to call this in our score manager as it does not know when actually to add a score. Therefore, we will need to do this in a different script. So have a think about when do we actually want to add to our score? Well, we would like to do this whenever the player successfully avoids the boulder, which means that when our boulder goes off the screen and needs to respawn, that's when we want to add to our score. So it would make sense for us to go into our boulder behavior script, and somehow in our respawn boulder, we would like to add to our score. Normally, when you want to get a component, we would use the get component method, but since this component is not on the game object that this script is attached to, which is the boulder, then we can't use the get component. So that's why we want to access an external game object. So let's say we wanted to access our player controller for some reason. Well, we would have to add a field. Let's just add a private player controller. Let's just name it player controller. And then in the start method, we would set our player controller to be equal to object dot find first object by type. We would now need to specify the type, which is player controller. And then we would end with parentheses and semicolon. And what this does is that it returns the first active loaded game object that matches the specified type. So the first game object which has this component on it. I will leave a link for the Unity documentation in the description. And now we can access the methods of the player controller. So we could go to a respawn boulder method, player controller, use the period sign for extensions, and now we can access all the methods which our player controller contains. Of course, we do not want to use the player controller, so that's why the next challenge for you is, instead of adding and calling the methods of our player controller, instead try to access the score manager and call the method add score. I'll give you a quick sec to pause the video, and then you can come back to see my solution after giving it a good go. So first off, as we did with our player controller, instead we will be adding a private score manager. I'll just call this score manager as well. And now we need to go to a start method and set the score manager to object.find first object by type. Which type would we like to find? We would like to find our score manager. And of course the parentheses and semicolon to end the line. Now we can go into a respawn boulder. Be careful with not calling the score method out here outside our if statement. We only want to call it each time our boulder needs to respawn. So therefore we will call it inside the if statement by using score manager add score. We will save the script. Notice that we're calling the find first object by type in our start method. That's because the start method is only called once. We could do it in our respawn boulder method, and that would work the same way, but then the method would be called each time a boulder respawned. What the method essentially does is it scans our entire hierarchy in the scene we're in until it finds a game object with the score manager component on it. If we were to do that continuously, then that could really decrease the performance of our game. So that's why we're making sure that it's only called once. And then the last thing we need before we run our game, we will need to go to our canvas object, and we will attach the score manager script as a component. You can see text in a variable called score text of the type tmp text. Therefore, we will drag our score text here into this field. So now when we run our game and avoid the boulder, the text will change. But it's changing the text to score, and it is actually increasing our score, but we can't see our score right now. So now comes the next challenge for you. Instead of just setting the text to being score, we would like to show our actual score. Again, pause the video, give this a good go, and then you can come back to see my solution. So to change this, I will just add a colon here and then spacing to make sure we get spacing between score and our actual score. And I'll just use the plus sign outside of the quotation marks, and I will add our score. So when that's done compiling, we can again try to run our game. And you can see now it has score 1, and each time the boulder respawns, our score will increase by 1. The last thing I want to do here is change the score text to just show our score as 0 when we start the game, so it doesn't just show new text. And yeah, this looks pretty good. So now we've successfully added our scoreboard to our game. But you might have noticed the problem is that when the player is destroyed, the game continues and the score continues to be increased each time the boulder respawns. That's not what we want. Here we would like to pause our game and add some kind of game over menu and an option to restart the game. So to create a game over menu, we want to make sure that we have 3 things. We want to have a screen which shows game over. We want to make sure to pause the game so the player can no longer move and the score can no longer increase. And then finally, we want to add an option to restart the game. The first thing we're going to do is we're going to go to our canvas object in our hierarchy. We're going to right click on this, go to UI, and then create a panel. This will become a child game object with the canvas as the parent. And let's just rename this to game over screen. Now you can see if you head to your game tab in the Unity editor, there's this sort of foggy layer on the game now. This is your panel. You might be able to see it here in the scene view as well. It's of course completely up to you how you want your game over screen to look. I like mine to be a bit darker than the game view, and I like to make it a bit transparent. I will go to the color property here in the image component of my game over screen. I will set it to black, and then using this slider at the bottom, I can decide which level of transparency I would like on my game over screen. And if we drag our slider all the way to the right, the screen will be completely blackened. If we slide it all the way to the left, this is how a game normally looks. I would like to just make it a bit darker, so I think I'll keep my transparency level around 80. Now that we have our game over screen, we would like to place some text and a button on it. So we're going to right click on our game over screen in the hierarchy. I'm going to go to UI again. I'm going to choose the text mesh pro element. I'll just rename this to game over text. And then in the inspector on the right, I'll change my text to be game over. Don't worry about the placement of the text for now. We'll get to that later. Now I will add my button. So I will go to my game over screen once again, right click, go to UI, and then you can see we have an option here called Button Text Mesh Pro. This button will be used to restart the game. So I will call it Restart Button. And you can see you can expand this button because you actually have a text element underneath it. So I will change the button text to be Restart. So now when we run our game, we have our text and we have our button. It's weirdly placed and nothing works. So let's try to fix that. To give some functionality to our game over screen, we would need what is called a game manager. Basically a game object which handles the state of the game. So I will go to my hierarchy. I will right click and I will create an empty game object. I will name this game manager, and then I will go to my scripts folder and create a new model behavior script, and I will also call this game manager. Again, remember your naming of the objects in the scripts do not matter. This is just how I like to name my objects. But before we start editing the script, let's just have a think about what we want to do. Firstly, we want to make sure that the game over screen is hidden, so this does not show up instantly when you play the game. Then we want to make sure to stop the time, so the game pauses and the score can't increase anymore. And then we want to have an option to restart the game. So let's start with the first one, game over screen is hidden. To make sure something is hidden in the game, we want to make it inactive. If you watched my earlier videos, I talked about enabling and disabling something, making it either active or inactive. You can do this by going to any game object in your hierarchy, then tick or untick this box. So now it is inactive, now it is active. Let me just show you in the game view real quick. Now when I untick this box, our player disappears because it is now inactive. It can't interfere with anything else in the game and it will be invisible. But when I make it active again, it is again visible. So we actually want to do the same thing for our game over screen. We want to untick this box. So now our game over screen is invisible when you start the game. But let's just say for whatever reason, we forgot to set the game object as inactive in our editor. We want to make sure that it's still set as inactive in our script. So to set it as inactive, first we need to access the game over screen. For this, I will create a serialized field. It will be a private game object, and I will just name it our game over screen. Now, if I wanted to set this to active instead of inactive, what I would do is access our game over screen variable, and I would use the period sign to access the extension methods. And there's this method called setActive. As you can see, it activates or deactivates the game object according to the value of the supplied parameter. What is the parameter we need? We need a bool. So if I wanted to set it to being active in the parameters, I would put true. So here comes a challenge for you. Instead of setting this to be active, we want to set the game over screen to be inactive. You can go ahead and pause the video now, give this a good go, and then come back to see my solution. It's fairly simple, really. The only thing we actually got to do is to change this from true to false. So now when we start a game, this is inactive. Just to show you this actually works, I will save my script. I will reactivate my game over screen game object in the hierarchy. And then of course, we also need to go to our game manager and then attach our game manager script to this as a component. And it takes in a game object, game over screen. We will need to drag our game over screen here into the inspector. So now before I run the game, you can see that the game over text and a restart button is visible on screen, and this checkbox is ticked. But when I run the game, text disappears, this goes unticked. So now we know that this line works, and if we accidentally forgot to deactivate our game over screen in the inspector, then the script would make sure to deactivate the game over screen. Now that this part is out of the way, we actually need to add an extra part, which is reactivate our game over screen. Because right now it is invisible, but we need to activate it again when we get the game over. I will actually not be using the update method for this script, so I will be deleting it. And now we can create our next method, which will be a public method. It will have the return type void, and I will name this trigger game over. So in here, we need to reactivate our game over screen and we need to stop the time. So the next challenge for you is to reactivate our screen. Pause the video, give this a good go, and then come back to see my solution. What we want to do is just access our game over screen variable once again, use the set active method, and this time we want to set it to true. So now that this is reactivated, we want to pause the time. We can do this by accessing the class called time, and we will use the variable called timescale. So we can read from the description here, the scale at which time passes, and it takes in a float. When your game runs at normal speed, this float is set to 1f. So to pause the game, we just need to set it to 0f. So I will set it equal to 0f. Now, when trigger game over is called, the time stops and the game can continue. So now we actually have these two out of the way as well. Now the last thing we need to do in the script is restart the game. So I will create another public void method and I will call this restart game. So when we want to restart our game, we want to reset our timescale and we want to reload the current scene. Resetting the timescale will be the next challenge for you. If you remember, up here we set it to 0f, and by default, the timescale is set to 1f. So pause the video, give this a good go, and then come back to see my solution. So to reset the timescale, we just need to set it back to what the original value was. So to do this, we will once again access the time class, then the timescale variable, and this time we will set it to be equal to 1f. Now our timescale is reset, and now we need to reload the current scene. With our current using Unity Engine, we don't have the tools in our toolbox to do that, so we need to add some more tools. We will this time be using the Unity Engine scene management. So as the name states, this is for managing scenes, loading, reloading, skipping to the next scene, etc. So now we can go back to a restart game method and we can access the scene manager. We will use the method load scene. Loads the scene by its name or index in build settings. So let's just quickly cover what are the build settings. If you go back to the Unity editor, go to file, you can see what is called build profiles. This is build settings. We open this up and you can see here we have something called a scene list. Right now we've only added our sample scene. So we have our scenes folder and the name of the scene called sample scene. And this has the number 0. So this is the index of all the scenes we have in our game. And if we go back to the Unity editor, we can see here in our hierarchy that we are currently in the sample scene. So this checks out with the scene list that we have in our build profiles. So in short, this is normally where you would add multiple levels to your game, but in this game we will only have one level. So we will just stick to the original scene list with the sample scene as the only one, head back into Visual Studio. And now for the parameters, we could choose to add a string with the scene name, so sample scene. We could choose to add an integer, which would be our index for the scene. As you saw before, our index was 0. But since we only have one scene, it would make more sense to make sure that this is the only scene we want to load. So instead of using the scene name or the index for our scene, we will be using the scene manager get active scene. So this, as the name states, gets the active scene, so the scene we're currently in. Remember parentheses because this is a method. And then we will use an extension method. So .name. Save this script, go back into the Unity editor, and when we run our game, nothing actually happens. Now, why is that? That is because we haven't told the game explicitly when to actually call the trigger game over method. So we need to do that someplace in our game. So let's just have a quick think about when do we actually want to trigger the game over screen? Well, we want to do that when the player and the enemy collides. The place where we handle this in our game is in the collision handler script. So this if statement checks if our player collides with our boulder. So when the player and the boulder collides, we want to find the game manager and then call the trigger game over method. In an earlier video of this series, we used the boulder behavior script to find the score manager and then call the method add score. So we will be doing the same this time. We will be typing object.find first object by type. Which type of object do we want to find? We want to find our game manager, and then we want to use the extension method, which is trigger game over. So let's try and save this script. And now when we run a game, you can see the game over screen is inactive. Our score increases each time the boulder respawns, but when we collide with our boulder, the time is stopped, the boulder stops moving, our score no longer increases, and our game over screen is shown. But the placement of our text and our button is still a bit off, and when we try to press our restart button, nothing actually happens. So let's just firstly get the placement of our text and our button correct. I will go to my game over text. I will be repositioning my text object by going down in the inspector and then setting the alignment to being center. And I will just move it up a bit. I'd also like to increase my font size a bit. And now I can reposition my button. I'll go to my button game object in my hierarchy, and I'll just move it a bit downwards. And then I'll just scale it up a bit. So to make sure I don't have to edit each one of these boxes, I'll just hit this little link icon, and this will make sure that when I edit one axis on my scale, it will edit all of them. So yeah, I'm happy with that. That looks pretty good. Now that we've gotten our placement correct, we need to make sure that the button actually does something. And this is the reason why we've set our method restart game to be public. This is so that the method could be called by pushing a button. And you can see if you scroll down in the inspector, there's this on click component. So this is a list of the events which happens when we click a button. We will hit the plus sign to add a new event. And in here, we need a game object which contains the script or the method we want to use. So we will drag our game manager into this field. And now we can open up this drop down menu and we can go to our game manager script. And here you can see a long list of methods, and we actually have the method called restart game. So now when we run our game and the game over screen activates, we will hit the restart button and the game will restart. And you can actually see this works for the entire scene. So now our score is 2, but when we hit our restart button, the score is reset to 0. So the last thing we need to add to finish our game is to add sprites, a background, and finally to manipulate with the player sprite so it's looking in the right direction depending on where we're moving. So to add sprites to a game, firstly we need to find them. There are plenty of places on the internet to find free sprites, but I often go with opengameart.org. Here you can search for any kind of sprite, music, animations, textures, whatever you can think of you could be needing for your game. And I have found these three sprites, one of a human character I will use as my player. I have found these 2D cave textures. One of these textures I will use for my background. And lastly, I have found this boulder. I will leave links for every asset I use in the description of this video. So in short, we're just going to go to the file section of every page, hit the link. If you downloaded a zip file, extract the files first, and then you can just drag the files into your project tab. Firstly, I will create a new folder. I will call this imported assets. Just to keep my structure clean, I will open up the folder, and in here I will drag the downloaded assets. So now we have our boulder, we have some cave textures, and we have our character. So now let's get to changing the actual sprite. Let's start with our boulder. What we want to do here is to go to our boulder game object in our hierarchy. Here you can see the sprite renderer component, and it takes in a sprite. So I will drag this PNG I have here, I'll drag it into the sprite field, and now our boulder has changed. It is a bit more green in the picture. That's because originally we set our color to be green, so we can set our boulder to be any color we'd like. I quite like this blue one actually, and you've maybe noticed this ring around it. This is actually our circle collider. Ideally, we would like the size of the sprite and our collider to be matching. I think the sprite is a bit too small for my case. That's why I'm actually just going to scale the sprite a bit. So I'm going to hit this link button to make sure it scales in all axes at the same time. But the collider of course scales with it. So I'll go to my circle collider component. I will click this button to edit the collider, and I can sort of drag this in around the edges so the collider kind of matches with the boulder. The boulder may be a bit small, but that's okay for now. Now that we've changed the sprite of our boulder, let's change the sprite of our player. I will just frame my player object. I will go to my player sprite, and then I will drag this image of the player inside my sprite field. You can see it's a bit reddish as well. That's because of the color we've chosen. But if you want the original color, you just have to set the color to be white. And again, the size of a collider and an actual sprite don't really match. So I will just fix that quickly. And yeah, now I've added my colliders. And you can see it has these two floating bits. I don't really know what they are, but I quite like the human sprite itself. So I will just keep this as is, and I'll leave the collider off the floating parts. If I wanted to, I could edit these bits out. You can do this pretty easily by using any photo editing program. So now that we have our player and our boulder, let's create our background. A very easy way to create a background would be to just create a new square sprite. I'll just take my square sprite and rename it to background. Instead of the original square sprite, I will just add one of these cave textures. And then we could actually just scale this background up a bit and place it correctly. So now in the game, we have the stone wall looking background. I will just say that there are better and more optimal ways to create a background, but for this kind of game, this is all we really need. So now we have the sprites for the boulder, the player, and the background. This is starting to look much better. But the thing that looks kind of weird is that when we walk to the left, our player is walking backwards. And we would like to change that in the player controller script. So we will go to our player controller script because this is where we're moving our player, and we want to manipulate the sprite of the player depending on which direction we're moving. First off, we would like to access some kind of component on our player. If we go to our player game object, what could we possibly edit here to manipulate the sprite? Well, a good guess would be the sprite renderer. So let's try to get that component. We will create a private sprite renderer. Let's just call it sprite renderer. And in the awake method, we will set our sprite renderer to be equal to get component. And what component do we want to get? We want to get a sprite renderer. We could manipulate our sprite in the move method, but I would like to keep a low level of abstraction, so I will create a separate method for this. I will type private void. I could just call the method flip sprite, but I like to be explicit with the naming of my methods to make sure that a reader knows what they actually are doing. So I will call my method flip player sprite. Now, how do we know when we actually want to flip the sprite? So right now, by default, our player is always looking to the right, and when we are moving to the left, we would like the sprite to flip horizontally and make the player look to the left. So when moving, we're actually reading a vector 2. So right now, when I stand still, the value of our movement.x is 0. But when I move to the right, holding down D, it will be positive, so 1. And when I hold down A to move left, it will be negative. It will go to -1. So we can actually use this x value to check which direction we're moving and flipping the sprite accordingly. So we have our movement variable up here, and I will use an if statement saying that if our movement.x is less than 0, then I will access my sprite renderer variable, and here we have a bunch of extension methods, and we actually also have a method which is called flipx, so flips the sprite on the x-axis, which is exactly what we want, and we will set this to true. As you may have noticed, this method now has 0 references and it's grayed out. This is because this method is not called anywhere. We want to call it where we register our input, so therefore this method will be called in our update loop. So up here we will call our flip player sprite method, and now when we run our game and move to the left, our player sprite flips. But we still have a one slight problem. When we are moving to the right again, the player sprite remains flipped. Therefore, we want to head back into our script and make sure that when we're moving to the right, the player sprite is flipped back. And this seems like a really good time to give you the next challenge. So make sure that when we're moving to the right, the player is flipped so it's turning correctly. Pause the video now, give this a good go, and then you can come back to see my solution. So right now we're checking that if the x value is less than 0, so when we're moving to the left on the x-axis, then we want to flip the sprite on the x-axis. So basically now what we need is to do the exact opposite. So we will use the else if statement and say that if the movement at x value is larger than 0, so if we're moving to the right on the x-axis, then the sprite renderer .flip x will be set to false. And now when we run our game and move to the left, our sprite is flipped on the x-axis, and when we're moving to the right, it is flipped back. I hope this video helped you out. If it did, please consider leaving a like and a comment, as this helps me out a ton, and subscribe for more content like this. Thank you for watching.